Okay, good afternoon to all of you. This is a subject area I will be mainly talking about air quality. Probably all of you must be knowing is a general knowledge question about air quality, what all is happening in Delhi every time you will be hearing, and then health. These many people will die because of air quality is going bad and all those. Those are the news which are there. As compared to what you must have heard so far in Earth system modeling, the AI entry in air quality is very new. But because reason is that air quality was not given that much importance until recently, about 5, 7, 10 years back, as it would have been given because subtle effect is not visible. Then climate change came and then climate change took over. So this always remain as a kind of a secondary subject as we are all concerned about weather and all those. So much before air quality, people start thinking because even the science or process of air quality and many things is still fundamentally is not known. And second thing is the data volume about air quality all over the globe is relatively low. Specifically in India, it is really low. So, and you all know about that AI is all about huge amount of when you have a data and then more and more all those. So, what I will be talking about is giving you little bit of a introduction of what is this over air quality paradigm altogether, why AIML is going to be a paradigm shift if we get into this in air quality science with a constant that amount of data required is much, much low as compared to what it is there in weather and climate. But still how we can got into. And then there are two examples which are very preliminary examples which we did it and then try to make these things. For example, when I came in 2022 in Bengaluru, then we were not having a hotspot identification. Hotspot means the places where pollution is very high. Bangalore, the problem is because of the geography, because it is at the altitude. In spite of the fact that you have so much traffic, so much congestion, which is not, in fact, it is worse than Delhi. Even then, air quality is very good because it is being blessed by good weather and geography. But still, you know, the places where emission sources are coming, they are one of the worst places, which is worse than even Delhi. Those, what we call is a hot spot, where the emissions are getting generated, like traffic junctions and all those places. So what I'm trying to tell you is that this is the kind of a introduction what in Indian city, and you must have heard there are a number of pollutants we talk about, but mainly in India, in a urban India, major problem is something which is called PM 2.5 and PM 10. What is that PM 2.5, PM 10? Is a particle which you cannot see visibly from the naked eye, which has a diameter less than or equal to 2.5 micrometer. So they are so small. Since they are smaller, when you inhale, your natural system cannot stop them. And normally some of them get stopped as we go bigger and bigger. So PM 2.5 is the particles which are measurable, which have a lot of data. As on today's science, maybe down the line in 10 years, PM1 becomes an important when the technology comes to do and lot of work is done. As you go smaller and smaller, it becomes more and more dangerous because you can inhale them. In addition to that, there are gases like, you know, ozone, nitrogen. Last talk, you must have heard about a lot of simulation being done for ozone, but most likely probably it was, I didn't see hear fully, probably it is in the stratosphere. So always remember ozone has a dual effect to the humankind. One is very good ozone when it is there in the stratosphere above 15 kilometer. But below 15 kilometer, it is a poison for you. So increase ozone here is a curse. Increase ozone in the stratosphere is a bliss. So this is something, and then these are all written here that 67% of the people in the country are exposed to bad air quality and all those things. And now as we are trying to, community of air quality is trying to come up with a improvement in air quality. Of late, governments are giving a lot of importance and lot of realized the fact that this subject is really harming both human being as well as the crop. So we try to find it out. These are the still gaps which are existing. Very inadequate monitoring stations are there. Then data is not being shared, which is anyway problem in all of the scientific thing, but weather it is becoming and climate is becoming more and more transparent now. But air quality is still a problem because it is not only sharing the data, but it has a lot of implication in terms of a different treaties. Then emission inventory is something which is accounting the sources of pollutants. So 100 vehicles are there, 4-wheeler, 3-wheeler, burning diesel or petrol, and then from there it is coming. Then as we have a weather related, that seasonal forecast is there, extended range forecast is there, then short-term forecast is there. Still the air quality, we have not mustered that kind of a expertise so far. That is the reason that in 2010, India's first air quality forecasting system, SUFFER, which came, and we could able to do that, because this has a prediction of air quality has a lot of repercussions, in the sense that if you know 3 or 4 days in advance, those people who are suffering from asthma or something, if they do not know that air quality today is going to be bad, they will not take the machine or inhaler which you are having, but at least if you know, they will take it so that emergency situation do not come into the. Okay. Now this, I already told that why AIML people started thinking in this line, because there has to be some advantage. Then only you talk about some new subject area. And as during the last decade, so many availability of the data available, then computational power, specifically parallel computing, has becoming now, especially in India, there is a lot of upliftment is there in IITM, Ministry of Sciences and all those. Then there are toolkits which are coming mainly in other areas, but then people are getting into that also. Now, one of the important thing which like weather, it can change its outcome at any point of time within no time. If it is supposed to be raining in the morning, you predict there is no possibility, there is a possibility, sometime probability, it may not rain when you are predicting. Similarly, in air quality also, it is highly dependent on the weather system. So if weather system gets perturbed, so in air quality, there is one more uncertainty is left. First is that your weather protection should be very good, which drives the air quality. And in addition to that, whatever the air quality parameters you are having, emission inventory and other things, that also has to be very good. So added uncertainty is put into that. Then traditional model struggle for non-linear relationship, because again, then there are two important things we should do. One is that emission inventory, which is like a static parameter. This much mass is released by burning 1 liter of diesel or petrol. When it comes in contact with weather, it goes different kind of either chemical reactions are transported. Then it converts into volume. And whatever we talk about air pollution, it is nothing but a mass concentration, is a volume. So that is the air pollution. That is. So these two things you should always remember. Then emission inventory enhancement. So the sole thing which came out is that if we are having a proper estimation of the sources which pollutes us, which emits, then I think we will be able to do much better job in simulating air quality. Otherwise, if we do not know what are the sources, we are missing the sources. At least in weather we know, mainly natural sources are there. But here it is all man-made sources are there, which drives in addition to those natural sources. So these are the significant slamming the process by reducing the reliance on periodic. Now the point came that, for example, take a Bengaluru as a case study. There is a different kind of a vehicles going from a different roads. There is a different, congestion is there. What kind of a vehicles are going in a particular, only some places are there when you heavy duty vehicles are allowed. They go, somewhere cars are there, somewhere two-wheelers are there. A year or 2 years back, we did a very extensive survey of analyzing manually also that in each of the major traffic junctions, what is the combination of different vehicles. So there are two ways by which emission inventory can be developed. One is you calculate the data, you collect the data from the transport department, and from there you said these many vehicles are sold in this particular year of a different size, different types, and then last 10 years what kind of a, 20 years what kind of a, that is available in the Vahan portal, and then calculate in. But you will not know from there, out of these, how many are there on the roads and how many are going every day from a particular road. That can be only done when you will have a survey. So people used to, we used, when I was talking about 2010, when we started in Delhi in a Commonwealth game, we deployed something like 150 to 200 volunteers, students, all of them of your age. And then we are given a click counter of them. 6 of them are standing in one particular roads and putting two-wheeler, another fellow three-wheeler, four-wheeler, car, and every traffic junctions, how many vehicles, you do that. But then always there is a uncertainty in finding out the number. You cannot make it out just like that. And then you have to come out with every hour in a particular road, what kind of a volume of different kind of a vehicles are there. Then the biggest, more complicated job is that you have to ask them that how old is your vehicle. That is how we will come to know the technology. Is a stroke 1, 2, 3, 4, all those. And your emission depends on the technology also. All those. That is why, Bharat stage 1, 2, 3, 4, 5, 6, all this coming. So that is the reason that this is also nobody knows. So you have to go and interact within 30 seconds or 1 minute to the person. There is also the biggest uncertainty. This was something which was going on. How level is this vehicle? And another thing is that VKT is another terminology, vehicle kilometer traveled. So normally, on an average, how many kilometer every day your vehicle runs? These are all those. So now, if you are given a kind of a facility where you put a drone, take a video, and with this video, even if you can, firstly, you identify the vehicles of a different kind of a vehicles. And second one is, if you can read the number plate. These are the challenges. Then you analyze your video and then see the number plate, identify them. From number plate, you will come to know. From the Vahan portal you go, you know exactly when it has been purchased, which is a tier 1, tier 2, whatever the kind of a stroke 1, 2, 3, 4, 1, all those things are there, how much kilometer, everything you will get it from there. So if that is done, all those manual thing is not, and this is exactly the reason that the AIML come in picture. That increasing the accuracy of the data, what we call is the activity data of a different roads in a city was the biggest hurdle. Then another thing is that in the village, in the suburb, in the slums, people cook food. So there, wood burning, coal burning, kerosene, all those are there. Now, one example how it comes, an error comes in that one. This is practical example in 97% of the slums in Bengaluru has taken LPG connections. So if you go with the government data, you will see that all the rampant burning of the wood, kerosene or charcoal is all gone, because 97% is biofuel is a zero emission, something like that. But when you go to the, then another thing is, whatever are the slums which has been shown in the map, with those who are having authorities, you will not even find somewhere multi-story buildings have come. Somewhere which are shown a barren land, green land, where the zero emission, big slums have come out. So how do you know all those? So if you have an aerial view from the drone and understand land use, land cover kind of a thing, then this need to be embedded with manual this thing. So when we have sent people, volunteers, so it is not that when you are putting a drone or AIML, you don't have to do manual thing. We found that 46, not more than 46% of the people who are using LPG. Everyone, 96, 90, not even 96, even 100% people have a LPG connection. But their one LPG connection, one cylinder lasts for 2 years. So when they have a very important function in their life, which they've considered is a very big one, they have to impress someone, then they will use, make a tea in this one. Otherwise, a monument is kept on the corner with every day, and the lady is cleaning and it is shining everywhere. So this is the situation which was there. So now if you go with the government data, you will have a biofuel emission 0. And when you go, your emissions are increased by 50-60%, and that biofuel emissions are very harmful emissions. That is the reason that one fact I will tell you, cataract, motiabin, you know all of them? This is basically in the Western country, is a male-dominated disease. In India, it is a woman-dominated disease. Why? Because most of the population is about 70% population is in the villages, and majority of them using in a non-ventilated area with a small kid nearby, and they are exposed to those harmful pollutants. So anyway, this is something, so I will go now a little faster. Then traditional quality control and quality assurance method is a fixed threshold manual inspection, which can miss subtle error to take significant time. So so what I am trying to impress upon you by showing these slides are that there are huge factors of uncertainty if you try to go with the traditional methodology. I am making a case for AIML lovers. Then advanced receptor modeling, that is also one of those, receptor I will give these slides so you can have it. So, but then I'm not going to too much in detail on that how these models often rely on still assumptions and how if you are using the AIML, I am not yet come that how you are coming to AIML, it can work on that particular thing. Then there is a low-cost sensor these days. That is the very biggest problem. There is a traditional sensor, which is Government of India all over the world, US EPA approved, which there is no problem at all. They are the best. They are like a Bible. So those are there. But that cost you one full set about 1 crore rupees. That's about, $0.1 million. One station. Then you can't have these many stations. You need to have. So now one new terminology came, which is what called is the low-cost sensors, portable sensors. They cost you some 5,000, 10,000, 15,000. 10 lakh rupees, one sensor, here 5,000, 10,000 rupees per sensor. See the difference. But the biggest problem is that for these sensors, you have to take care of like a baby. It is so sensitive to many things and all. So it is failure. So far, no international agencies have approved that, although everybody is telling there is a big potential in that one. In India also, or it is cannot be used for the purpose of executive for these things, understanding for the advisory purposes, but then fill up the gap, it can be done. Now, when everything has got failure and everything, AIML came as a big hope for those fulfilling the gap. And that is where that AIML, if you have a modeling, what it will do, that it will collect the data, it will go back to the traditional one, it will try to simulate, do dispersion, and it will recalibrate your local sensors. With these, where in the vicinity, so in the vicinity you have a 50 local sensor, one traditional center, then it is sufficient to do the thing. So that is again another hope which is coming. Now, this I am talking, BUD is Bangalore Urban District. So it is not only Bangalore, this area, everything comes into that, which we did it. This is our team, this is our institute NIAS, which you can see in the left-hand side. And those are the volunteers, you know, those greenish, bluish shirt, where they are going to different people asking for the details, very limited, 5 questions, which can be answered in 30 seconds. So, as I told, that when you develop emission inventory, one is the activity data and other are mathematical, other things are there, but I'm focusing on this. These are the different sources, but there are different sectors are there, about 20, 25 sectors are there, where you can see the hotspots, like a hospital parking lot, some huge tourist spot, parking lot, that becomes a hotspot. Not only the traffic junctions. So those things you need to find it out from there. So in Bengaluru, when we started doing this, we found the following gaps. Mainly emission inventory which has been done using the data. Nobody knows that which road goes with how many kind of vehicles are going from each roads and all. Simply, you got it, 5 lakhs vehicles are there of 2-wheeler or 3-wheeler in Bengaluru, divide it, so everywhere is the same, and then calculate by thing. Once you calculate one number emission, then you distribute it uniformly or any other kriging method or whatever in GIS. But realistically, you don't know. Somewhere there is a huge pile of vehicles like Habel Junction. Habel, you will find almost stagnation. You will take 10 minutes to go, get 2 red lights will have to cross. But there are many places where it is a free flow of traffic. When there is a free flow of traffic, not much pollution. But when there is a stagnation, slow moving traffic, huge emissions are coming. So these are the no emission hotspot identified previously. And that is where we came up with this methodology. These are our volunteers. As I told that these blue greenish shirts are for our volunteers. They did it, gone for months together. So traditional method, then we use the this thing. Now, not going in too much in detail, but I will go to the little bit. These are kind of a framework which we try to do it with the drone-based AIML technique for accurate and precise activity data generation. HD videos, frame counts, then optical character recognition, then vertical vehicular speed, object identification, vehicle composition, optical character recognition, and vehicle specification. In between, OpenCV, YOLO, probably many of you must have heard about this also. If not, you should Google and try to find it out. These are fast-moving software which are coming up, which are also readily available, and some of them also we are in the process of developed many other things. But on an average, this is the thing by which you get these many informations. Now, this is the way you have a collection of the data. So vehicles are going in the still capture. This is the still capture, but then we took a capture for the video. Mainly the video image processings are there. What way we did it? Some traffic junctions, more, then all those still capture and all those kind of things in a different places. And then object identification with the yellow V8. And there you are putting up this. So this is now only used in this is object identification. So this is only object identification, two-wheeler, three-wheeler, four-wheeler, what kind of vehicles are there. Initially, we were finding it difficult. For example, if there is a khaka for this, cigarettes or something, a small lakdi ka, in many junctions you will see where you get tea or something pot. It has identified as a lorry, is mini truck. So how you come out of that? Similarly, the parked vehicles are there, which are also recognized as the vehicles on those. Those are the nitty-gritties and all you need to work on that. And so this is the object identification. One of these are the way. Then with the yellow, you have to do. So then number of iterations, number of corrections in this, all those things were required. Then character recognition. This was one of the biggest challenge, and it is still an open challenge, that you need to recognize the number plates. Color, if it is a yellow, it is a commercial. If it is white, it is this, as well as numbers. From there only you will find out its age and then engine types and everything. So that was a challenge, but then try to do that. And moreover, every time your camera, different frames, we took it in different angles. But certainly there will be 5 to 10% where you can't, the camera can't capture because it is hidden somewhere, number plates and everything. But we tried our level best to try to do that kind of thing. Then speed also, that what is the speed by which it is running, whether it is optimized or not. And these are the two objectives whose distance is known were identified and tagged along the road, acting and distance marking, number of video frames that is taken in a vehicle data and close to 2 market count. Then so many things, since distance was that. Then finally, the FPS, since the drop capture video at steady 60 FPS by accounting the frame, time to cross can be found. And with all those algorithm, all the mathematics, whatever you have, this is a validation. That example is morning 8 to 9, 9 to 10, 10 to 3, up to midnight. Validation is what? These are the four-wheeler count in each hour. Where it is written NIAS, that means it is manually counted by the volunteers, 10, 20 people. When it is for automated, means it is a drone. And we try to see, we consider that when you are putting a lot of volunteer, 10 volunteers or so, and getting it counted, then manual counting would be more accurate. And that will serve as a validation to your drone AIML related calculations. And that is what in a Saraki circle, you will get that more or less you will see that it is all coming very closer. Now, in between there is a fainted line is also there where only one this thing is there. So there we didn't take the observation. These are the assumptions you need to do that because in the initial stages, battery life for the drone at this stage is 45 minutes. Then you have a multiple drone and all. And moreover, we know that if we take in some key hours, then it can be interpolated, extrapolated at that time. For example, if you take 12 to 4, more or less the flow would be more or less uniform. Then after 4, it will start. Morning 7 to 10 is more difficult and all those. So these are, and then finally you have this and one portal you go. Then drone is only used to find distribution of vehicle, absolute vehicle data used to gross. Then the following assumptions were made. 25% of the vehicle registered before 2050 are estimated to be registered million. So you know that vehicle population in total is 9.7 million in Bengaluru. And another fact which I will tell you, Bangalore is the only city in India where two-wheeler population dominates as 70% of the total vehicular population in Bengaluru are two-wheelers. Remaining all are 30%. And that is the reason, that is one of the biggest problems also, because they are responsible for making congestion. They can go anywhere in between all. All of you must be, don't feel offended, but this is what it is reality, that so many area captures are there. So overall methodology is this: down survey, manual survey, government bodies, other AIML, emission factor, total emission, hotspot, graded emission, grid intersection, base grid. These are the automatically what you get it. And results. These are all something which for the scientific knowledge, but I will, based on all this AIML and everything, that in Bengaluru city, this you need not to bother because these are some numbers, tons per year is this much emission for. But for PM 2.5, transport sector amount to about 40% of the total emission. Then biofuel is 6%, industry is 24%, DG set is 5%, dust, resuspended dust is about 15%. This is the combination. But interesting facts are coming now. Okay, then this is again that how many are commercial, we could find out with the plate identification. How many on the road, which are commercial, which are buses, which are car, two-wheeler, and these are the combination, vehicle and Bengaluru. Then these are the 80 major hotspots of emission in the region we have identified. And these are the from the BUD. And which is the one which is, has a maximum emission. So those are the places we should avoid staying longer. You can pass, but don't. Now, the important, important message which is satisfying this particular slogan, that minimum effort, maximum benefit. And that is what I'm trying to tell you, that just 0.28% of the total area of Bengaluru urban district accounts to 21% of the emission of PM 2.5. You are getting point? Let us not look into this. Look for the top one. So if you take a mitigation or take actions on that 20.20, not even 1% of the total area, you are saving this much pollution in those 80 hotspots, instead of going to total 100 by 100 kilometer. So those are something which are similarly, if you go to another 300 semi-hotspot region, another that semi-hot is 1.28%. So total less than 2% of the area, you can stop around 40% of the emissions of PM 2.5. Once you do this, you are in business. Then you come well within the permissible limit. So anyway, we had given this recommendation to government and pollution control boards and all, based on those. This is just for the sake of this. And this is also one of my students did PhD on that. I think he has basically worked with partially with Bipin Kumarji also. This is a student who, that is his work which I have been showing. What he has done is that artificial neural network, he has a data for ozone, and from using the data, he has made a predictions for ozone and VOC, volatile organic compound. And using the AIML and using the observation, he tried to see what is the error, and he has got a very promising results. This is, I can tell you, these are complicated. These are observation system, which is called air quality monitoring and weather. This is volatile organic compound, then data cleaning, then satellite, you have a data, what we call is a reanalysis data. All this data with the observed data, you data clean, then MLDL model. This is where your AIML models are there. Then simulation using varied input parameters. Then ozone prediction results. And then featured important estimates. And then after doing all those, he tried to, compare with the real observations in the prediction. These are in the prediction mode, by the way. So you did. And so finally, this is what is the flow chart by which observed data, pollution, meteorology, same thing, whatever is shown, data quality change, field, then convert the data into the time series supervised data sets, split the supervised data into training for 2 years, 65% of the data, use remaining supervised data as a test set, 1 year, then within model, hyperparameter tuning, select the appropriate input data size, variation of input parameter, put in the model, best training set prediction results, and finally get best test for ozone protection results. So this is the total flow which is being done, and these are the results and which is very expected and predicted. I think that is something which was expected, means these are observations. The blue one, and I think is very promising. These are the results. So I think with this, I stop my talk. Thank you.
Thank you very much, Dr. Beig. So do you see any online questions are there? And in the meantime, I can take the questions from here. There is one mic somewhere. No? No, it's here. Okay, then I, yes.
Two party people are waiting to enter the Zoom meeting. Can you please admit them? One of them is the next speaker.
Sir,
But anyway, you can go ahead.
You mentioned two algorithms. One is YOLO.
Yeah.
One is YOLO and one is paddle. Can
Right.
you tell us about what those algorithms are, and like what are the specific use cases, and what these algorithms are preferred over any other algorithms which might be available?
You see, the point is that these are the one which are ready-made. People have made it commercialized as on. But I think these are very simple algorithm, and anybody, it is a emerging area. Looking at those are available on the in an open platform. You can develop on you. The only thing is that what shape, character identification, and speed. Those are the parameters which you need to find it out with the trend of the model. So those are the things which are available. It become very famous. Tomorrow you will become very famous. You can come out with a better version of that, but not many. It is no, it's not a matter of convenience. It is a matter of when your model can give the best possible maximum parameter, best possible results in a testing. Yes.
Hi, sir. Thank you for the talk. My question was about using the traffic signals. The traffic signals that already exist in Bangalore have vehicle actuated controls. They're already taking pictures, maybe 24/7 of the vehicles. So do you think that it would be a good idea to include these to augment the data?
No, we did also got that, but those data are good in a general thing, in a sense, identification of the number of vehicles are all. But the tilting angle to capture the name, the number plates, everything, for which you, I mean, there are a lot of information which are missed when you process that data. So that is.
Hello, sir.
Yeah.
So I wanted to ask, how often do you need to update the emission inventory?
In fact, it is supposed to be updating every year, because the way our country is a developing stage, number one. Number two, next 5 to 10 years are going to be as frequently as you can do, because we are now transiting to the EV, electrical vehicle, from the fossil. So huge amount of change will come. So we need information whether we gained something with the EV. Obviously, we will gain. Theoretically, we are going to gain. But realistically is what? If you do all these manual counting and everything, 6 months goes in the campaign itself, by the time you require a result. And that is where the AIML come in picture even much more strongly. So the answer of your question is, every year you should have to have an update.
So in reality, at present time, how often is it updated?
5 year. In fact, many places it is not even available, the emission inventory.
Thank you, sir.
Hello, sir. I have two questions.
Yeah.
Like in Kolkata, I have seen there is a time limit of entering the heavy vehicles in the city. Like after 10 p.m. it can enter. So is it a feasible solution for improving the air quality? Like you have provided, like there is separate lane for this.
Okay. Very good question. In fact, this first thing is, if vehicles are entering whatever maybe the time or something, it is going to add up to the total overall emission. There is no doubt, because finally it is not hourly emission. It comes out to be per day or per month and per year. So it got into that, number one. Number second is that weather condition, if such, where, for example, if temperature is very high, humidity is very high, that time is vehicles are increasing and the wind speed is very slow. That time, if you allow them to enter, and that is what exactly happens, because in the night time they allow huge loss. That time it get accumulated. It never get drifted, the emission. So weather conditions should also, and those weather conditions would be best when in the afternoon. And that is the time when you would like to avoid the traffic. Don't want it to enter into that. So it is getting into this kind of a.
And my second question is, like from the drone, how many data points you can get from the drone? Is it enough to train a DL model?
Yeah. You see, that is where that, for example, we are taking sorties, 5-minute sorties 3 times. This is the bare minimum we could do, looking at the limited resources. Obviously, huge data sets, if you are having, accuracy will increase even more and more, but you need to optimize. But this is what we, so that was sufficient.
Thank you, sir.
Any other question from audience?
Yeah, sir.
Yeah.
Yes. Yeah.
And maybe it was for the city. Maybe if you have done the similar experiments, like the second case, if you have data from different cities, maybe they all can be used for federated learning, and then maybe you should have.
Exactly. This is what, see, this is done for the first time only in Bengaluru, as far as in the subject we know. But emission inventories are existing in many cities, which is a mandatory requirement, but not all the cities. Major cities, it is all there. So if we have this kind of a data, many other, you are very right that at least we will have a huge volume of the data, and then you train model much and more, and accuracy will certainly increase. So well taken your point. This need to be recommended.
Yeah, okay. So I also have the question about
Yes.
the drone. See, how frequently you are taking the, you are taking still image, not the video.
No, video.
You are taking the video.
Yeah.
So I saw that you have taken the video and then you are capturing the number plate which are on the front. But you see that when it is the traffic light is red, okay, then there is a lot of overlap. The scooters you cannot check, see if it is behind the bus or truck. And once the green light is coming, it just moves faster and they can go here and there. So there will be always mistake to take actual count of the two-wheeler and capture the number plate. That is the problem. Do you have any like solution for this problem?
See, that one thing I missed it because it was taking time. In one traffic junction, 5 minutes, 3 rounds, 5 times. Why? Because when there is a traffic light, only in one side there is a flow. Others are a stagnation. So we do not concentrate on those who are standing over there.
Yeah,
we are only taking this thing. Then when that light is stopped, you concentrate on that other side of that. So that is the reason that, for example, if there are 4 lanes which are going in a different side, that is 1. So addition of all within that 5 minutes time of the red light is going to be the total number of vehicles. So that is something which I didn't tell. But coming back to your question, that with the different angles in a different times, we try to see the number plates problem. And that is one of the biggest problems. For example, two-wheeler getting a number is one of the most difficult tasks getting. So that is a lot of uncertainty. That is why we got it something like.
Asking solution because I'm the same situation.
Yeah.
The same thing I'm doing for Pune. So I feel this problem. I'm taking the data directly from the CCTV from this smart city office from Pune. Second thing.
It's about 86% accuracy, by the way, in the two-wheeler number. Otherwise, it's a 96, 97% accuracy.
Yeah, but now they are putting, the smart city people, they are putting very high resolution camera at the 2-3 angles also.
Right.
So, I mean, and that is continuously they are taking. So I get the data like even a minute and seconds data also available. But still finding the number plate sometimes difficult for the overlap. Second thing, when the vehicle is going, suppose the first vehicle immediately we catch it. The vehicle coming behind, how many times you are checking the video, how you are tracking the vehicle, whether are you tracking that within this junction, it has passed through in 20 seconds or 30 seconds like that.
That vehicle are assigned a number.
Number is assigned.
So that number is tracked.
Number is tracked, but I have seen your flow chart, you are saying YOLO 8 is used just for the classification. There is nothing tracking. After the classification,
speed.
we have to track it.
In the speed. When
speed is just measuring the frame, number of frames also to even capture the classification. But after this is the junction. The vehicle came, you identified this is a car. But this car took how much time, how many seconds to go from here? Because that time it is doing a lot of emission because it was stopped and a lot of emission coming. How many seconds is stopped there? And that also counts a lot of emission at that particular junction. So the tracking is, I don't know whether you have the tracking has been done or you have not put into that flow chart. That's what I did not see.
No, that's the thing.
So number plate was running parallel to YOLO. Number plate is running. I know YOLO is for the classification and now the YOLO 8 and now I have a YOLO 11 also. So number plate is very nicely we are capturing. Okay, the thing is tracking. So we have to add another algorithm, another software for tracking. That is the part of the YOLO. That is the part of YOLO. Yeah.
So we can track that ID and see how the vehicle is moving in that given view
frame. So the vehicles are tracked. See, there are number of advantage of tracking a vehicle. What I have shown is the speed. Because of the speed, also we track. So with a different with this, but this is one of the another thing that
there are so many problems, and the biggest problem is after getting the number plate, you got the number. You cannot get the whole thing from the van as a citizen. You have to get a person from RTO, the transport department. They don't give full information.
No. We have to we took a permission.
Yes,
we to purchase.
That's what I was asking.
No, it's not a freeware.
Every person cannot get all the information. You cannot get even name also. You will get this. So this is the car, maybe the year,
but
not the stage and all.
That was the advantage with the government.
Yes. Then you can. You have the runtime live access, live access. API live access you have. Then you can calculate this.
Yes.
Okay, fine. Thank you. So, still any other question? We have 1 or 2 minutes. Okay. So I will pass.
Yeah. Who is
Sir, I have one question regarding to the challenges you mentioned. So you mentioned one of the challenges is that getting data from the low-cost sensors, and they are not very accurate also. You have to calibrate it again and again. And the amount of low-cost sensors also we have less. So earlier in one of the talks by Dr. Neera from C-Step, Bangalore, so they said they are operating a sensory network which has around 60-70 low-cost sensors in around Bangalore. So how about you get the data from them? Is there anything like that possible? Like they are also taking air quality measurements, like PM 2.5 and all this. So is there a possibility that you can get data from them and you can give them data? Because seems like both are the same type of data and you have the same problem.
Okay, see, there are two things. What I said is getting a data from traditional, which are foolproof kind of a thing, is it is very limited because it cost. And in Bengaluru, we are having just something like 12 or 14 stations all through Bengaluru. These are the ones which are the most reliable one, which is what can be used for the executive purposes. The low-cost sensors are booming in the market heavily. Systep is one of them, which are collaborating with number of manufacturers and doing. So you talked about 60, 70, but I am telling you, summing together, maybe some 400-500 in Bengaluru city. But the point is that they all suffer with the quality control and quality assurance. And so far, we have not reached to the level where you can develop a AIML algorithm which can connect to the traditional one, combine this low-cost sensor data, and come up with the refined one. So the recalibration, taking care of them, using algorithm which has not been developed. They are working as a silo, and this is working as a silo. Because of the fact that this all big one is owned by the government of India with the Pollution Control Board. The fact that government of India has not recognized them as a useful instruments, unless because of the quality control, they are not meeting together. So maybe as a startup, as a youngsters, or as an educational researcher, you can suggest, well, I would like to do a research project where this is the agency which do the low-cost sensors, go to Maharashtra, the Karnataka Pollution Control Board, get a data from them, and then try to, well, you need not to get, it is available in the open portal data for, then you develop that thing. That would be a very, very good thing. So that is a potential problem.
Sorry, last question. So in this data which you have taken, it is mainly for emissions, right? But if I'm not wrong, in Bangalore, there are also a lot of construction activities in the urban places, and they also generate a lot of PM2.5. So have you considered in future or in nearby that what is the role of construction along with this emission side, especially in those?
You must have seen one sector was there, dust emission. That is the dust coming from the two sources. This is not a natural dust. It is a dust from the construction activity and dust which is a resuspended dust. How the resuspended dust is? If there is no wind, I think the dust which is here will not fly much. But when the vehicle is moving in a paved and unpaved area, is a higher the speed, higher the lift of that. That is what we call is a resuspended dust. So there is an algorithm by which we calculate with the trajectory, and there is the reason that that we want to know the speed of the vehicles. Now you know there is very interesting thing in Delhi that number of vehicles have increased by 40% in last 10 years. Emission of transport sector has gone up by 40%. Dust emission from 45% is came down to 20%. So it is improved. Then everybody was surprised that dust emission has decreased in Delhi. Wow, everything. But why it is decreased? Construction activities are increased, vehicles have increased. There is no where that all the greenery, open spaces become green. That is also not happening in this. Why? Because the average speed of the vehicles from 45, it has reduced to 25. So when they are going on the move, so it is a blessing in disguise.
Okay, so we will close this session, but we will again thank to the Dr. Beig for this. It was very, very enlightening talk and very interesting topic. Everybody enjoyed. I see the faces. Okay.
I'm glad that this will motivate some of the students, some of the people who come up with a like OLO or YOLO or some other kind of a software. And I have already, in fact, you yourself have pointed out and I have confirmed that these are the gaps. To work on that. And this area, even in air quality, is going to grow. I'm 100% sure.
Okay, good. So here he has given a challenge that already we have the YOLO 11. If you can come with some other algorithms, a better version of YOLO, then it's a good, good, contribution. Okay, so now I hand over to Adway.
By the way, your contribution need not be just YOLO. You could come up with a different framework also.
Capturing the video, capturing the object in the video. Not only vehicle, it has been used for many places, for many governments. No, that's fine. That's fine. I'm saying there's so many